A single mistake before a crane ever lifts a load can lead to equipment damage, serious injury, or even loss of life. The surprising part is that many of these accidents happen during site setup, not during the actual lift. If you are preparing for the NCCCO Crane Operator exam or planning to work as a crane operator, this is knowledge you cannot afford to skip. Stay with me through this complete study guide because every section builds on the last, and you can also download a free study guide packed with the most important exam questions using the link in the description. In this first section, you will learn how to evaluate a job site, inspect ground conditions, recognize hidden hazards, and prepare your crane for a safe and successful lift. These skills will help you answer exam questions with confidence while developing the habits that every professional crane operator needs on the job. Let's begin by building the strong foundation that every safe and successful lift depends on. The very first thing you must do upon arriving at a job site is to identify the controlling entity. The controlling entity is usually the general contractor or the site supervisor, and they are responsible for ensuring the ground is properly prepared to support your crane. On your exam, you will need to remember that the crane operator is not legally responsible for preparing the ground, but you are absolutely responsible for inspecting it before setting up. Never trust a patch of dirt just because someone tells you it is safe. Ground bearing pressure is a critical concept you must understand for both the exam and the real world. Ground bearing pressure is the amount of weight the crane exerts onto the soil below it, which changes every time the crane swings or lifts a load. When you pick up a heavy load and swing it over the outriggers, all that weight transfers down through a very small area. If the soil cannot handle that pressure, the outrigger will sink, and the crane will tip over. To prevent the crane from sinking, we use supporting materials called blocking and cribbing. Blocking refers to the solid pads or mats placed under the crane outrigger floats to distribute the weight over a larger area of ground. A common exam question will ask about the correct sizing of blocking, which must always be significantly larger than the outrigger float itself. The rule of thumb is that the blocking must be strong enough to prevent crushing and large enough to safely spread out the pressure. When you set up your blocking, it must be completely flat and tightly packed together without any gaps. The outrigger float, or pad, must be perfectly centered on the blocking to ensure the weight is distributed evenly across the entire surface. If the float is placed off-center, it creates uneven pressure that can easily snap the wooden mats or crack the fiberglass pads. Always make sure the blocking is placed on firm ground, never on top of loose debris, mud, or uncompacted fill dirt. Another major hazard you must constantly look for during site evaluation is underground voids. An underground void is an empty space hidden beneath the surface, such as a sewer line, a water pipe, or a newly excavated trench. If you set up your crane too close to a trench, the immense weight of the crane can cause the trench wall to collapse instantly. You must always maintain a safe distance from any trenches, usually keeping the outrigger at least as far back as the trench is deep. Moving away from the ground, the sky holds one of the deadliest hazards in the crane industry, which is overhead power lines. The Occupational Safety and Health Administration, or OSHA, has very strict rules regarding how close a crane can get to energized power lines. For lines rated up to 50 kilovolts, you must maintain a minimum clearance distance of exactly 10 feet at all times. This 10-foot rule applies to every single part of the crane, the load line, and the load itself. If the power line voltage is higher than 50 kilovolts, the required clearance distance increases significantly. For every additional 10 kilovolts over the initial 50, you must add almost half a foot of extra clearance distance. However, in the real world and on the exam, you will use specific OSHA tables to find the exact required distance based on the specific voltage. If the voltage is entirely unknown, you must assume the worst and maintain a minimum clearance of at least 45 feet. One of the most common mistakes new operators make is forgetting about line swing when working near power lines. When the wind blows, or when you swing the crane too quickly, the load and the wire rope will naturally sway outward. If you set up exactly 10 feet away from a power line, a strong gust of wind could easily blow your load right into the live wires. You must always account for the maximum possible sway of the line and the load when calculating your safe working distance. If you must work closer to power lines than the minimum clearance distance allows, you have to contact the utility company. The utility company has the authority to either de-energize the power lines or install insulating blankets over the wires. Remember for your exam that the crane operator cannot make the decision to work closer to live power lines without direct permission and intervention from the utility owner. Until the lines are confirmed dead or covered, you must treat every single wire as if it is fully energized and extremely dangerous. Before setting up the crane, you must also evaluate the site for proper swing clearance. Swing clearance refers to the physical space needed for the crane counterweight to rotate without hitting anything. The counterweight is the heavy block at the back of the crane that balances the weight of the load in the front. You must ensure there is a minimum of 2 feet of clearance between the counterweight and any obstacles, like buildings or parked vehicles. If you cannot maintain that 2-foot clearance around the counterweight, you must take immediate action to protect workers on the ground. You are required to set up warning barricades or safety tape around the entire swing radius of the crane. This prevents ground workers from accidentally walking into the swing path and getting crushed between the heavy counterweight and a solid object. Protecting the swing radius is a mandatory safety requirement that will definitely show up on your certification exam. Leveling the crane is another crucial part of site preparation that directly affects your lifting capacity. Cranes are engineered to lift loads perfectly straight up and down, which means the crane itself must be perfectly level. You must use a carpenter level or the electronic level indicator inside the cab to ensure the crane is sitting flat on the outriggers. If the crane is not level, the load will swing out of radius as soon as it leaves the ground, creating a highly dangerous situation. Even a small leveling error can cause massive reductions in your safe lifting capacity. If a crane is off level by just 1 degree, it can lose up to 10% of its overall lifting capacity. This happens because being off level introduces side loading onto the boom, which is a twisting force the boom was not designed to handle. Always double check your levels before every single lift, especially after swinging a heavy load, because the ground can settle and shift. When extending your outriggers, it is crucial to pull the crane tires completely off the ground. The tires should be hovering in the air, meaning 100% of the crane's weight is resting on the outrigger pads. If the tires are still touching the ground and bearing weight, the crane is basically sitting on shock absorbers, which makes it very unstable. On the exam, always remember that outriggers must be fully extended and tires must be completely clear of the ground for maximum chart capacity. Some cranes allow you to lift loads on rubber, which means lifting without using the outriggers at all. However, you must carefully evaluate the site ground conditions because lifting on rubber requires a perfectly flat, solid, and smooth surface. Your load chart capacities will be severely reduced when lifting on rubber because the tires are far less stable than extended outriggers. Furthermore, your tire pressure must be inflated to the exact specifications listed by the manufacturer before you attempt an on-rubber lift. Weather evaluation is the final major component of site preparation that we need to discuss. Wind is the invisible enemy of the crane operator, and you must check the weather forecast before starting your shift. High winds can catch a large load like a sail, pulling the crane forward and potentially causing a structural collapse. Always know your manufacturer's maximum wind speed limit, and do not be afraid to shut down operations if the wind gets too strong. Lightning is another severe weather hazard that requires immediate action on the job site. The boom of a crane acts like a massive lightning rod, making it one of the most dangerous places to be during a thunderstorm. If you see lightning or hear thunder, you must immediately lower the load to the ground, lower the boom if possible, and leave the crane cab. Never try to finish a lift during a lightning storm, as the risk of a fatal strike is incredibly high. Cold weather also affects crane setup, as freezing temperatures can drastically change ground conditions. Frozen ground might seem rock solid in the morning, giving you a false sense of security when setting up your outriggers. But as the sun comes out and the ground thaws, the soil can suddenly turn to soft mud, causing your crane to sink on one side. You must continuously evaluate the ground throughout the day, especially during changing weather conditions, to ensure your setup remains completely secure. Congratulations on completing this highly important section on site evaluation and crane preparation. I strongly encourage you to complete the attached practice test right now, while this information is still fresh in your mind. Answering practice questions is proven to improve your memory retention and ensure you are fully prepared for the real exam. The practice test is included right here with this lesson, so take advantage of it to reinforce your active learning. Great job so far, and I naturally look forward to seeing you in the next section where we will explore technical knowledge and crane components. Welcome back to the course as we step into Section 2, where you will master technical knowledge and crane components. In this lesson, we will explore the inner workings of hydraulic and lattice cranes, wire rope construction, critical safety devices, and strict inspection rules. Understanding how these mechanical systems work is crucial because it keeps your equipment running safely and forms a massive part of your certification exam. Get ready to gain a deep technical understanding that will set you apart as a professional operator. Let us jump right into the anatomy of these powerful machines. To start, you need to know the major structural differences between hydraulic cranes and lattice boom cranes. A hydraulic crane features a telescoping boom made of nested steel sections that extend outward using internal hydraulic cylinders. A lattice boom crane, on the other hand, uses a fixed structural frame built from welded steel tubes that must be manually assembled to the desired length. Hydraulic cranes offer fast setup times on busy job sites, while lattice cranes excel at reaching extreme heights and carrying massive loads. Looking closely at a lattice boom, its strength comes from a clever engineering design consisting of main cords and lacings. The main cords are the four heavy steel corner tubes that run the full length of the boom section. The lacings are the diagonal steel tubes welded between the cords to absorb twisting and bending forces. On your exam, remember that if even one lacing tube is bent or cracked, the total structural capacity of the entire boom is dangerously compromised. Hydraulic booms rely on internal components to operate smoothly under heavy loads. Inside the telescoping sections, manufacturers install wear pads made of durable plastic or brass. These wear pads cushion the sliding steel sections, preventing direct metal-on-metal friction and keeping the boom sections aligned correctly. Inspecting these wear pads for uneven wear is a key operator duty, as worn pads can cause the boom to jerk or slide out of alignment. At the very top of any crane boom, you will find the boom tip assembly, which houses the sheaves. Sheaves are heavy grooved pulleys that guide the wire rope from the hoist drum down to the hook block. The grooves in these sheaves must match the diameter of the wire rope almost perfectly. If a sheave groove is worn down or too small, it will pinch the wire rope, causing rapid wear and structural failure of the rope. Positioned near the boom tip sheaves is one of the most vital safety systems on the crane, known as the anti-two block device. Two blocking occurs when the lower hook block is pulled up so high that it slams directly into the upper boom tip sheaves. This collision can easily snap the wire rope, causing the load and hook to drop instantly on workers below. Preventing two blocking is a primary safety requirement on every job site. The anti-two block system uses a suspended weight hanging from an electrical limit switch near the boom tip. The main wire rope passes directly through the center of this hanging weight. If the hook block rises too high, it lifts the hanging weight, which opens the switch and immediately cuts off dangerous crane functions. Specifically, it stops you from hoisting up, telescoping out, or lowering the boom, preventing a catastrophic collision. Next, let us turn our attention to wire rope, which is actually classified as a complex machine with moving internal parts. Wire rope consists of three basic components, which are the center core, the individual steel wires, and the multi-wire strands. Individual wires are twisted together around a center axis to form a strand, and multiple strands are then wrapped spirally around the central core. Each component moves and shifts slightly against the others as the rope flexes around sheaves. You will need to know the difference between two primary core types, which are fiber core and independent wire rope core. A fiber core is made of synthetic or natural rope materials, offering high flexibility but poor resistance to heat and crushing. An independent wire rope core, abbreviated as IWRC, is actually a small wire rope inside the outer strands, providing superior strength, heat resistance, and crushing resistance. Most modern cranes use an independent wire rope core due to its durability under heavy working conditions. Wire rope is also categorized by its lay, which describes the direction the wires and strands are twisted together. In a regular lay rope, the individual wires are twisted in one direction while the strands are wrapped in the opposite direction. This opposing construction makes regular lay rope stable, easy to handle, and resistant to untwisting under load. Right regular lay is the most common wire rope type you will encounter on standard mobile cranes. Rotation-resistant wire rope is a specialized rope engineered to stop the load from spinning while hanging in the air. It uses an inner layer of strands twisted in one direction and an outer layer twisted in the opposite direction, creating balancing forces. Because of its unique construction, rotation-resistant rope is more delicate and prone to internal damage. On your exam, remember that rotation-resistant rope requires stricter inspection standards and lower safety factors than standard wire rope. Performing wire rope inspections is a crucial daily task that requires recognizing specific removal criteria. One major reason to remove a running wire rope from service is finding broken wires. For standard running ropes, the rule is to remove the rope if you find 6 randomly distributed broken wires in one lay length, or 3 broken wires in a single strand in one lay length. A lay length is simply the distance along the rope it takes for one strand to complete a full turn around the core. In addition to broken wires, you must inspect the wire rope for severe physical deformities. Core protrusion occurs when the inner core pops out between the outer strands, destroying the structural integrity of the rope. Birdcaging happens when sudden stress release causes the outer strands to open up like a cage. If you discover a birdcage, a kink, or severe crushing on a wire rope, that rope must be taken out of service immediately and destroyed. The wire rope is stored on and pulled by the hoist drum, which can have either a smooth or grooved surface. When spooling rope onto the drum, it must wind tightly and neatly in even layers without overlapping or crossing over. An extremely important safety rule to memorize for the exam is the minimum wrap requirement. You must always maintain at least 3 full wraps of wire rope on the hoist drum at all times, even when the hook is at its lowest point. Modern cranes feature controlled load lowering mechanisms to ensure loads descend safely and smoothly. Power load lowering uses hydraulic pressure to drive the drum in reverse, giving the operator complete control over the speed of the lowering load. This is much safer than older friction drive free fall systems, which relied on mechanical foot brakes to slow down a falling load. Most modern safety regulations require power load lowering when hoisting structural steel or personnel. Electronic safety systems play a massive role in modern crane operations, led by the Load Moment Indicator, or LMI. The Load Moment Indicator is an onboard computer that receives data from sensors measuring boom angle, boom length, and hydraulic pressure. It continuously calculates the actual weight of the load and compares it to the crane manufacturer capacity limit. If you approach an overload condition, the LMI will sound an audible alarm and lock out dangerous functions to prevent tipping. Hydraulic safety is another critical area, especially regarding outriggers. Outrigger cylinders use hydraulic holding valves, often called pilot-operated check valves, directly mounted onto the cylinder bodies. If a hydraulic hose bursts while supporting a crane, this holding valve instantly locks the fluid inside the cylinder. This prevents the outrigger from collapsing under the weight of the crane, avoiding a sudden tip-over accident on the job site. Inspecting the crane hook is just as vital as inspecting the wire rope and hydraulic components. Hooks are made of forged steel designed to bend slowly under extreme loads rather than snapping without warning. You must inspect hooks regularly for cracks, twist, and throat opening deformation using precise measuring tools. On your certification exam, remember that a hook must be discarded if its throat opening has expanded by more than 15%, or if it is twisted by more than 10 degrees. All of these technical checks come together during the daily shift inspection, also known as a frequent inspection. The crane operator is required to perform and document this visual inspection at the start of every single work shift. You must check fluid levels, test all safety control switches, inspect wire ropes, and verify that all operating controls respond correctly before making your first lift. Performing thorough daily inspections ensures minor mechanical issues are caught before they turn into major job site disasters. Congratulations on finishing this detailed section on technical knowledge and crane components. Now is the perfect time to complete the attached practice test to test your understanding of components, safety systems, and inspection rules. Completing practice questions will greatly boost your memory retention and prepare you for the exact style of questions on the certification exam. The practice test is included right here with this lesson, so dive in and reinforce what you have learned today. Excellent effort, and I look forward to guiding you through our next section on load dynamics and rigging fundamentals. Welcome to Section 3, where we dive deep into the fascinating world of load dynamics and rigging fundamentals. In this lesson, you will learn how physical forces affect a suspended load, how to locate the center of gravity, and how to safely select and use rigging gear like slings and shackles. Understanding these concepts is essential because even a perfectly set up crane can fail if the load is improperly rigged or moving out of control. Mastering load dynamics will give you the skills to handle any object safely and pass your exam with high scores. Let us jump right in and master the science of lifting. The most important physical property of any load is its center of gravity, often abbreviated as CG. The center of gravity is the exact single point where all of the object's weight is perfectly balanced in every direction. When you hook up a load, its center of gravity will naturally swing directly below the hook point as soon as it lifts off the ground. If your hook is not centered over the center of gravity before lifting, the load will tilt and swing wildly, creating a dangerous hazard for everyone nearby. A crane operates on the basic mechanical principle of leverage, acting just like a giant playground seesaw. The crane's tipping axis, which is the front edge of the outriggers or tires, serves as the fulcrum of this seesaw. The weight of the crane behind the tipping axis works to keep the machine grounded, while the weight of the boom and load in front tries to tip it forward. Understanding leverage helps you realize that extending the load further away from the crane dramatically increases its leverage and tipping force. In addition to static weight, an operator must constantly manage dynamic forces during a lift. Dynamic forces are extra loads created by movement, such as starting a lift quickly, stopping abruptly, or swinging too fast. Sudden motions create high shock loads that briefly double or triple the actual weight felt by the crane and rigging. Smooth, controlled control movements are required to keep dynamic forces as low as possible throughout the entire operation. Swinging the crane too fast introduces centrifugal force, which pushes the suspended load outward away from the machine. As the load swings outward, it increases the working radius, which is the horizontal distance from the center of rotation to the hook. Increasing your working radius automatically reduces the crane's safe lifting capacity, potentially pushing the machine into an overload condition without you even extending the boom. Before lifting any object, you must determine its total gross load weight, which is far more than just the weight of the object itself. Gross load includes the weight of the material being lifted, plus all rigging hardware, the hook block, the headache ball, and any wire rope hanging below the boom tip. On your certification exam, you will be expected to calculate gross load accurately by adding every single item attached to the boom tip together. Rigging hardware connects the load to the crane hook, and every piece of hardware must have a visible rated capacity. The rated capacity, or working load limit, is the maximum weight the hardware can safely support under normal conditions. You must never use unmarked rigging hardware on a job site because there is no way to verify its safe lifting strength. If the load tag or stamped rating is missing or unreadable, the hardware must be removed from service immediately. Shackles are one of the most common pieces of connection hardware used in rigging operations. They consist of a curved bow and a removable pin, available in screw pin or bolt type designs. When attaching a shackle, you should always seat the load in the bow rather than directly on the pin, as pulling on the pin at an angle reduces its strength. Additionally, never allow shackle pins to touch moving ropes or surfaces that could accidentally unscrew them during a lift. Rigging slings come in three main varieties, which are synthetic web, wire rope, and alloy steel chain. Synthetic slings are lightweight, flexible, and soft, making them great for delicate loads, but they are vulnerable to sharp edges and high heat. Wire rope slings are durable, heat-resistant, and strong, offering great reliability for general construction lifts. Alloy steel chain slings are extremely tough and heat-resistant, but they are heavy and require careful inspection of every single link. The way you connect a sling to a load is called a hitch, and different hitches change the sling's safe working load. A vertical hitch supports the full rated capacity of the single sling leg holding the load directly below the hook. A basket hitch wraps under the load and brings both ends up to the hook, effectively doubling the sling's lifting capacity if the legs remain vertical. A choker hitch wraps around the load and tightens down on itself, which actually reduces the sling's capacity. When using a choker hitch, the tightening action creates severe stress at the point where the sling chokes back onto itself. If the choke angle is tight, meaning less than 120 degrees, the sling capacity drops significantly below its standard rated limit. On your exam, Remember that a standard choker hitch reduces a sling's lifting capacity to roughly 80% of its vertical rating, requiring you to adjust your rigging math accordingly. Sling angles play a massive role in load dynamics and are a primary topic on the certification exam. When using a multi-leg sling, the horizontal angle between the sling leg and the top of the load directly affects the tension on each leg. As the sling angle gets lower and wider, the tension inside each sling leg increases dramatically. Understanding this concept prevents you from overloading slings during wide, low-angle lifts. To calculate the tension on a sling leg, you multiply the load weight per leg by the sling leg length, then divide by the vertical height. For example, if a sling is pulled down to a 30-degree horizontal angle, the tension on each leg becomes double the actual weight of the load. This occurs because the sling legs are pulling sideways against each other with immense force just to hold the load up. Always keep sling angles as steep as possible to minimize internal tension. Safety standards strictly forbid using sling angles that fall below 30 degrees from the horizontal plane. At angles lower than 30 degrees, the leg tension skyrockets to dangerous levels, making sling failure extremely likely. Furthermore, low sling angles create massive compressive forces that can easily crush the edges of the load being lifted. Always aim for sling angles of 45 degrees or higher whenever possible to maintain high safety margins. Hook positioning relative to the load's center of gravity is critical for maintaining stability during the lift. The main hoist hook must always be positioned directly above the load's center of gravity before lifting. If the hook is placed off-center, the load will slide or swing as soon as it clears the ground, shifting weight rapidly across the rigging legs. Taking the extra time to align the hook perfectly prevents dangerous pendulum swings. Unbalanced loads present unique challenges because the weight is not spread out evenly across the object. When lifting an asymmetrical or unbalanced object, the center of gravity will sit closer to the heavy end than the light end. This means the sling legs attached to the heavy side will carry far more weight than those on the light side. You must calculate the weight distribution individually for each rigging point to avoid overloading a single sling leg. Sharp edges on a load are a major cause of sudden rigging failures on job sites. When a sling is pulled tight against a sharp corner, the high pressure can slice right through synthetic webbing or severely kink wire rope. You must always use softeners, such as rubber guards, plastic corner protectors, or heavy wood blocks, between the sling and sharp edges. Softeners cushion the bend and protect the integrity of your rigging gear. Taglines are essential safety ropes attached to the load to control its rotation while hanging in the air. A tagline allows ground personnel to steer the load from a safe distance without standing directly under or near the heavy object. Taglines should be made of durable, non-conductive rope to protect workers in case of accidental contact with electrical sources. Riggers must never wrap a tagline around their hands or bodies while guiding a load. Daily inspection of all rigging gear is a mandatory duty for both riggers and crane operators. Look closely for signs of damage like cuts, tears, severe abrasion, heat damage, or broken stitches on synthetic slings. Wire rope slings must be checked for kinks, crushed areas, and broken wires, while chain slings must be inspected for stretched or twisted links. Any piece of damaged rigging gear must be removed from service immediately and cut up so no one uses it by mistake. Congratulations on completing Section 3 on load dynamics and rigging fundamentals. You have covered some of the most critical physics and calculations required for safe crane operations and exam success. Now is the ideal moment to complete the attached practice test while these important concepts are still fresh in your mind. Answering these practice questions will solidify your understanding and dramatically boost your test performance. The practice test is included right here with this lesson, so dive right in. Awesome job today, and I look forward to seeing you in Section 4 where we will conquer load chart navigation and calculations. Welcome back to the course as we begin Section 4, focusing entirely on load chart navigation and calculations. In this lesson, you will learn exactly how to read a manufacturer load chart, calculate gross capacity, and determine net capacity by making correct deductions. Load charts are the absolute most important tool in your cab, and they form a huge portion of the math questions on your certification exam. By the time we finish this section, you will feel completely confident working through complex load chart scenarios. Let us break down these numbers and build your calculation skills. A load chart is a legally required document created by the crane manufacturer that outlines exactly how much weight the crane can lift under specific conditions. You must always use the exact load chart provided by the manufacturer for your specific crane model, serial number, and configuration. Every load chart book contains multiple pages of data based on boom length, outrigger position, jib attachments, and counterweight setups. Your first task on any exam question is to ensure you are looking at the correct chart page. The two most important terms to understand on a load chart are working radius and boom length. Working radius is the horizontal distance from the crane's center of rotation out to the center of gravity of the load hanging directly beneath the hook. Boom length is the physical length of the telescopic or lattice boom measured from the boom hinge pin to the center of the tip sheaves. You will use these two numbers continuously to look up capacities on the chart matrix. When reading the main chart matrix, you will cross-reference your working radius against your boom length to find your gross capacity. For example, you look down the left column to find a radius of 40 feet, then look across the top to find a boom length of 80 feet. Where that row and column intersect is your gross capacity for that specific lift. If your exact radius or boom length is not listed on the chart, you must always choose the next longer or greater number to stay safe. It is crucial to understand the difference between structural capacity and stability capacity. Values shown above the bold line on a load chart represent structural capacity limits, meaning if you exceed this weight, something on the crane will break or bend. Values shown below the bold line represent stability limits, meaning if you exceed this weight, the crane will tip over before it breaks. The bold line itself is the dividing marker between structural failure and tipping failure. Gross capacity is the absolute maximum total weight the crane structure can safely support at a specific radius and boom length. However, gross capacity is rarely the actual amount of raw material you can pick up. Gross capacity includes the weight of everything hanging off the boom, including the load, rigging, hook block, and extra wire rope. Understanding that gross capacity covers all hanging weight is the foundation for solving load chart exam problems. To find out how much raw material you can actually lift, you must calculate the net capacity. Net capacity is simply the gross capacity minus the weight of all capacity deductions. Capacity deductions are all the extra items attached to the boom that take away from your overall lifting power. The basic formula to memorize is gross capacity minus deductions equals net capacity. Let us explore common capacity deductions you must account for in every calculation. The most common deductions include the main hook block, the headache ball, rigging slings, shackles, and any jib stowed on the boom. If you leave a stowed jib attached to the boom while lifting off the main boom tip, its dead weight must be subtracted from your capacity. Every manufacturer chart includes a specific page listing the exact weight values for these standard deductions. Wire rope deduction is a tricky concept that frequently appears on the certification exam. When you lift a load with multiple parts of line, meaning the wire rope loops down and back up through the hook block several times, that rope adds significant weight. You must calculate the weight of the wire rope hanging below the boom tip and subtract it from your gross capacity. Some older charts ignore wire rope weight, but you must assume it is a required deduction unless the manufacturer notes otherwise. Jibs and boom extensions are attachments used to reach higher or further, but they drastically reduce your overall capacity. When you lift a load off the jib, you must use a separate load chart specifically created for that jib attachment. The jib chart will usually base its capacities on boom angle rather than radius. Furthermore, lifting from a jib is almost always limited by structural strength rather than stability, so exceeding the chart limits will snap the jib instantly. If a jib is erected and pinned to the boom tip, but you choose to lift a load from the main boom instead, you still suffer a capacity penalty. An erected but unused jib creates massive forward leverage and wind resistance, so you must apply an erected jib deduction to your main boom capacity. This deduction will be listed in the manufacturer notes and is usually much larger than the stowed jib deduction. Always read the chart notes carefully to apply the correct jib penalty. The parts of line in your reeving system also dictate your maximum lifting capacity. The wire rope itself has a maximum safe working load, known as the line pull capacity. If the chart says your gross capacity is 50,000 pounds, but your single part of wire rope can only hold 10,000 pounds, you cannot lift the full 50,000. You must reeve multiple parts of line through the block to multiply the total pulling power of the wire rope system. Determining the correct number of parts of line is a standard calculation you must master. You take the total gross load you need to lift and divide it by the single line pull capacity of the wire rope. For example, a 40,000-pound gross load divided by a 10,000-pound line pull equals exactly 4 parts of line required. If the math results in a fraction, such as 4.2, you must always round up to the next whole number, making it 5 parts of line. Outrigger positioning is another critical variable when reading load charts. Most modern cranes offer load charts for fully extended outriggers, mid-extend outriggers, and fully retracted outriggers. If you cannot fully extend even one outrigger due to space limitations, you must use the mid-extend or fully retracted load chart for the entire lift. You can never mix charts or guess at capacities when outriggers are partially deployed. Manufacturer notes are the small paragraphs of text located at the beginning or bottom of the load chart pages. These notes contain vital safety rules, setup requirements, and specific deduction values that change how you read the matrix. Ignoring the manufacturer notes is the fastest way to fail a load chart exam question. Always read every single note before you attempt to look up a capacity or calculate a deduction. Let us walk through a full load chart calculation sequence. First, you determine your working radius and boom length. Next, you look at the chart matrix and find your gross capacity based on those two numbers. Then, you read the manufacturer notes to find all required deduction values. You add up the weight of the block, rigging, wire rope, and stowed jib to get your total deductions. Finally, you subtract total deductions from gross capacity to find your final net capacity. If you are calculating whether a specific load is safe to lift, you take a slightly different approach. First, determine the gross load by adding the weight of the raw material, block, rigging, and wire rope together. Second, find the gross capacity from the chart matrix based on your radius and boom length. If your calculated gross load is less than the chart gross capacity, the lift is safe to perform. Boom angle is occasionally used instead of radius to determine capacity, especially for lattice cranes or jib lifts. The boom angle is measured between the horizontal ground plane and the centerline of the boom. As the boom angle gets higher, meaning the boom points closer to straight up, the capacity generally increases. Conversely, as the boom angle gets lower, the capacity decreases rapidly due to increased forward leverage. Duty cycle operations, such as concrete pouring or steel erection, require special load chart considerations. These operations involve repetitive, fast-paced lifting that creates constant dynamic shock loading on the crane structure. Because of this extra stress, some manufacturers require you to reduce your standard load chart capacities by up to 20% during duty cycle work. Always check the chart notes to see if a duty cycle reduction applies to your specific lift. Congratulations on completing Section 4, focusing on load chart navigation and complex calculations. This is often the most challenging part of the exam, so I highly recommend you complete the attached practice test right now. Working through these math problems will build your confidence and ensure you know exactly how to apply deductions correctly. The practice test is included right here with this lesson, so take a moment to test your new skills. Fantastic work, and I look forward to guiding you through our next section on safe operating procedures and communication. Welcome to Section 5, where we master safe operating procedures and clear job site communication. In this lesson, you will learn the exact industry standards for crane operation, including standard hand signals, radio communication, and essential safety protocols. Clear communication is the absolute glue that holds every safe lift together, as miscommunication is a leading cause of job site accidents. By mastering these procedures, you will ensure total safety on site while mastering key operational questions on your certification exam. Let us dive into these critical communication and operating standards right now. On any active job site, clear roles and responsibilities must be established before the crane ever moves. The lift director is the person directly responsible for overseeing the entire lifting operation and ensuring all safety requirements are met. While the lift director plans the lift, you as the crane operator have the final legal authority to refuse any lift if you believe it is unsafe. Knowing who holds which responsibility is a frequent topic on the exam and a vital part of job site safety. Hand signals are the primary visual method of communication between the signal person and the crane operator. Standard hand signals are strictly governed by regulatory bodies like OSHA and ASME to ensure every operator nationwide understands the exact same movements. You must only accept hand signals from one designated signal person at a time to avoid confusion. If multiple people start waving signals at once, you must stop all crane movements immediately until a single signal person is confirmed. Let us review some of the most basic hand signals you will encounter on the exam and on the job site. To signal hoisting up, the signal person extends a forefinger upward and moves their hand in small horizontal circles. To lower the load, the signal person points their forefinger downward and moves their hand in small horizontal circles. Extending an arm horizontally with the thumb pointing in the direction of swing signals the crane to swing in that direction. Combination hand signals are used when you need to change the boom angle while keeping the load at the exact same height. To raise the boom and lower the load simultaneously, the signal person extends an arm with the thumb pointing up, while flexing their fingers in and out. Conversely, to lower the boom and raise the load, the thumb points down while the fingers flex in and out. These combination signals require smooth control manipulation to keep the load completely level. The emergency stop signal is the most important hand signal you will ever learn. To give an emergency stop, a person extends both arms horizontally and moves them rapidly back and forth across their chest. On your certification exam, remember that while standard signals must only come from the designated signal person, an emergency stop signal can be given by anyone on the job site. You must obey an emergency stop signal immediately, no matter who gives it. When visual contact cannot be maintained, voice communication using two-way radios is used instead. Voice signals must follow a strict three-part format, which includes the direction of movement, the distance of movement, and the instruction to stop. For example, the signal person will say hoist up 10 feet, 5 feet, 2 feet, and stop. Furthermore, radio communication must remain continuous throughout the lift, meaning if the radio signal cuts out or goes silent, you must stop the crane immediately. A blind lift occurs whenever the crane operator cannot physically see the load, the hook, or the destination area. Blind lifts carry a much higher risk level, requiring a fully qualified signal person positioned where they can clearly see both the load and the operator, or use dedicated radio channels. During a blind lift, you rely entirely on the accuracy of your signal person's directions. If you lose visual or audio contact with your spotter for even a single second, you must pause all movement right away. Before lifting any load off the ground, Standard operating procedures require you to perform a quick test lift. You should lift the load just a few inches into the air and pause to verify that the holding brakes are functioning properly. This brief pause also allows the rigger to inspect the slings under full load tension and verify that the load is balanced correctly. Taking a few seconds to test the brakes prevents a runaway load if a mechanical failure occurs. Controlling load swing is an art that every skilled crane operator must master to operate safely. When you start swinging or slewing the crane, the load will naturally lag behind the boom tip due to inertia. To prevent the load from swinging wildly, you must catch the swing by smoothly accelerating at the start and decelerating just as the boom reaches its target. Never apply the swing brake suddenly, as stopping abruptly will cause the load to violently overshoot the boom tip. Pick and carry operations involve lifting a load and physically driving the mobile crane to another location on the site. Carrying a load while moving introduces severe dynamic forces and changes in ground level that can tip the crane easily. You must keep the boom as low as possible, position the load close to the ground, and attach taglines to prevent rotation. Always drive at extremely low speeds over smooth, level ground during a pick and carry maneuver. Working near existing structures or physical obstacles requires extreme precision and constant vigilance. You must ensure that no part of the crane boom, load line, or counterweight comes into contact with surrounding buildings, scaffolding, or trees. When operating in tight spaces, dedicated spotters should be stationed around the crane to monitor clearances visually. Maintaining adequate clearance prevents structural damage to the crane and surrounding property. Leaving a crane unattended requires strict shutdown procedures to protect the equipment and the public. You must never leave a crane unattended while a load is suspended from the hook block. Before stepping out of the cab, you must lower the load to the ground, disengage the main master clutch, set all travel brakes, and shut down the engine. Securing and locking the operator cab prevents unauthorized personnel from tampering with the controls. Unexpected mechanical failures can happen on the job site, requiring calm and immediate action from the operator. If you experience a sudden loss of engine power while a load is hanging in the air, do not panic. The automatic mechanical holding brakes on the hoist drum will immediately engage, preventing the load from falling. Your primary responsibility in a power failure is to set the manual swing brake and keep the job site clear until power can be restored or the load safely lowered manually. Hydraulic hose failures represent another high-stress emergency situation during crane operations. If a main hydraulic line bursts, pilot-operated check valves locked onto the cylinders will instantly stop fluid from escaping. This safety mechanism prevents outriggers or boom sections from collapsing under heavy loads. You should immediately shut off the main pump to prevent hydraulic fluid from spraying, and clear all personnel away from the immediate area. Severe environmental conditions, such as dense fog or heavy rain, can severely impair your ability to operate safely. If visibility drops to the point where you cannot clearly see your signal person or the boom tip, you must stop operations. Operating in poor visibility increases the risk of striking unseen obstacles or misjudging distances. Always prioritize safety over schedule demands when weather conditions degrade visibility. Hoisting personnel in a suspended man basket is heavily regulated by OSHA due to the extreme risk involved. Personnel hoisting is only allowed when traditional access methods, like ladders or scaffolding, are completely impossible or more hazardous. When lifting workers, the crane must be operating at no more than 50% of its rated chart capacity. Furthermore, a trial lift with equivalent weight must be conducted at the job site before any human enters the basket. A critical lift is a complex lifting operation that carries a much higher risk of failure or property damage. Critical lifts generally include lifts that exceed 75% of the crane's chart capacity, multi-crane tandem lifts, or lifts over active chemical plants. Every critical lift requires a formal written plan created and approved by a qualified engineer or lift director before the operation begins. During a critical lift, the lift director leads a detailed pre-lift safety meeting with the entire crew. This meeting covers the step-by-step lifting sequence, exact load weights, weather limits, and designated communication channels. Every team member, from the crane operator to the ground riggers, must understand their exact role before the lift starts. Thorough planning and open communication are the keys to executing complex critical lifts safely. Congratulations on completing Section 5 on Safe Operating Procedures and Communication. You have gained invaluable knowledge regarding hand signals, emergency protocols, and essential job site safety rules. I strongly encourage you to take the attached practice test right now to lock in these important concepts. Working through practice questions will dramatically boost your attention and ensure you are ready for the communication portion of your exam. The practice test is included right here with this lesson, so dive in and test your knowledge. Excellent progress so far, and I naturally look forward to seeing you in our final section where we will master advanced scenarios and complete exam strategies. Welcome to our final section of the course, where we tackle advanced scenarios and exam mastery. In this lesson, you will learn how to handle complex operations like multi-crane lifts, navigate severe weather challenges, and apply proven strategies to pass your certification exam. This topic is incredibly important because it bridges the gap between basic operation and true professional expertise, ensuring you are ready for any situation. Get ready to pull all your knowledge together and build the ultimate confidence you need to dominate the exam. Let us finish strong and secure your certification. We will start by exploring multi-crane lifts, which are some of the most dangerous and complex operations you will ever perform. A multi-crane lift, often called a tandem lift, involves using two or more cranes to hoist a single heavy or oversized object simultaneously. Because the cranes are physically tied together by the load, any movement made by one operator directly impacts the other crane. These lifts require perfect synchronization, extremely precise communication, and a highly detailed engineering plan before anyone touches the controls. A vital rule to remember for your exam regarding multi-crane lifts is the mandatory capacity reduction. When two cranes are lifting a single load, the center of gravity can shift rapidly if one crane hoists faster or swings unevenly. To compensate for this sudden shifting weight, safety standards dictate that each crane must be downgraded to only 75% of its normal chart capacity. You must always calculate this capacity reduction to ensure neither crane accidentally becomes overloaded during a tandem lift. Maintaining perfectly level hoist lines is critical when operating multiple cranes together. If one crane lifts its end of the load slightly higher, the load's center of gravity will slide directly toward the lower crane. This shifting weight instantly transfers thousands of extra pounds onto the crane holding the lower side, which can easily cause a catastrophic structural failure. Both operators must maintain exact hoist speeds to keep the load perfectly level from start to finish. Adverse weather conditions create advanced scenarios that require quick, decisive action from the operator. Wind is the most common invisible hazard, and you must understand how it affects both your crane and your load. When wind strikes the boom and the load, it creates a massive side load that pushes the crane laterally, severely reducing structural stability. On your exam, you will need to know that manufacturer load charts do not account for heavy winds, meaning you must reduce your lifting capacity when the wind picks up. The physical size and shape of the load, known as the wind sail area, drastically changes how dangerous the wind can be. Lifting a large, flat wooden panel is far more dangerous in high winds than lifting a solid block of steel that weighs exactly the same. The flat surface catches the wind like a sail, putting immense backward or forward tension on the crane boom. Always evaluate the surface area of your load and consult your lift director if wind speeds approach the manufacturer's maximum limit. Extreme temperatures also play a major role in advanced crane operations. In freezing weather, hydraulic oil becomes very thick, causing the crane controls to feel sluggish and respond slowly during delicate movements. You must allow the hydraulic system to warm up properly before lifting heavy loads in winter conditions. Conversely, in extreme heat, hydraulic fluid can thin out, reducing pressure and causing winches or boom cylinders to slip slightly under heavy tension. Operating a crane on a floating barge is a highly advanced scenario that appears frequently on the certification exam. When a crane is mounted on a barge, the entire lifting platform tilts and shifts as the crane swings a load over the water. This tilting motion causes the load radius to increase automatically, reducing your lifting capacity dramatically compared to working on solid land. You must always use a specialized barge load chart provided by the manufacturer, which takes this aquatic instability into account. We touched on personnel hoisting earlier, but there are advanced rules you must memorize for the exam. When a worker is suspended in a manned basket, you are strictly prohibited from moving the crane or driving it to a new location. The crane must remain completely stationary while personnel are in the air to prevent sudden jarring movements. Additionally, the crane must be equipped with a positive locking mechanism on the hoist drum, and free fall functions must be physically locked out. Workers inside the suspended personnel platform must use proper fall protection systems at all times. The workers must wear full body harnesses, and their safety lanyards must be anchored directly to the master link of the rigging, not just the guardrails of the basket. This ensures that if the basket itself fails, the workers are still securely attached to the main crane hook. Protecting human life requires absolute perfection, which is why these strict regulations are tested heavily on the exam. Transitioning into exam mastery, the first and most important strategy is reading every question carefully. The certification exam is known for using tricky wording, double negatives, and subtle details that can completely change the meaning of a question. Never rush through the test, even if you feel confident about the topic being asked. Take your time, read the question twice, and make sure you understand exactly what the examiners are asking before you look at the multiple choice answers. When tackling load chart questions, your biggest enemy will be forgetting to check the manufacturer notes. The examiners will often provide a scenario that looks simple on the main chart matrix, but a hidden rule in the notes will completely change the correct answer. For example, a note might require a massive deduction for a specific jib configuration that you will miss if you only look at the numbers. Always read the fine print before doing any math on the exam. To avoid silly math errors, write down a physical list of all your capacity deductions on your scratch paper during the exam. Write down the block weight, the ball weight, the rigging weight, and any jib deductions in a neat vertical column. Adding them up on paper prevents you from forgetting a small item in your head, which the examiners will anticipate. They often include wrong answer choices that exactly match the math you would get if you forgot to deduct the rigging. Many exam questions will ask you to identify the weakest link in a rigging setup. You will be given the capacity of the crane, the capacity of the wire rope, and the capacity of the sling. You must always base your final safe lifting weight on the lowest rated component in the entire lifting system. If the crane can lift 20,000 pounds, but the sling can only hold 5,000, your absolute maximum safe load is only 5,000 pounds. If you encounter a question where you genuinely do not know the answer, use the process of elimination. Most multiple choice questions have 4 options, and usually, 2 of those options are completely illogical or unsafe. By eliminating the obviously wrong answers, you give yourself a 50% chance of guessing correctly. Never leave a question blank on the exam, as an educated guess is always better than an automatic 0. You will sometimes see questions asking what to do if an official safety regulation conflicts with the crane manufacturer manual. The absolute golden rule in the crane industry is to always follow the stricter of the 2 rules. If the government says you need 10 feet of clearance, but the manufacturer says you need 15 feet, you must follow the 15-foot rule. This principle ensures maximum safety and is a guaranteed point on your certification test. Managing your time during the exam is critical for success, especially during the heavy math sections. Do not get stuck spending 10 minutes on a single difficult load chart calculation while ignoring the easier knowledge questions. If a math problem is frustrating you, skip it, finish the rest of the test, and come back to it with a clear head at the end. Answering all the easy questions first builds your confidence and secures easy points early on. When reviewing your answers at the end of the test, trust your first instinct and avoid changing answers unless you find obvious evidence you were wrong. Many candidates fail because they second-guess themselves and change correct answers to incorrect ones during the last 5 minutes of the exam. If you did the math correctly and remembered the safety rule, have confidence in your training. You have put in the hard work to learn this material properly. Take a deep breath and realize how far you have come since the beginning of this course. You now understand site preparation, crane components, complex load dynamics, tricky load charts, and advanced safety operations. This comprehensive knowledge has prepared you to step into the exam room with total confidence and walk out as a certified professional. Keep reviewing the core concepts, stay calm under pressure, and trust the solid foundation you have built. Congratulations for successfully completing this final section and the entire Crane Operator exam preparation course. I strongly encourage you to complete the attached practice test one last time to truly lock in these advanced concepts. Explaining that practice questions improve your memory retention and overall exam readiness is the best advice I can give you before test day. Remember that the full practice test is included with this lesson, so take advantage of it to encourage your active learning. You are now fully prepared to pass your certification, and I wish you the absolute best in your new career.